Alright guys, welcome to this set of videos. What we're going to do here in the following videos is they're going to follow along with the notes that come out of your textbook from Chapter 4, Section 3. And what we're going to do is we're going to continue this theme that we've been looking at here of solving quadratic equations, but now we're going to kind of change gears a little bit. What we have been doing previously was we have been solving quadratics by graphing. And now what we're going to go ahead and do here in Section 3 is the exact same thing. We're going to solve quadratic equations, but now we're going to do it by using some algebra or factoring. So a couple of objectives or learning targets for you guys as you make your way through these notes, things you should be able to do by the time we get to the end of this note set and this set of videos. You should be able to write a quadratic equation in standard form. We're actually going to start with that objective. It's right here on the first page of the notes, which I'll explain to you, and then we'll take a look at a couple of example problems. But here's what's going to happen. If you're given the roots of the quadratic, the solutions, the x-intercepts, we want to be able to take those roots and write the quadratic equation in standard form that gives us those solutions. So we'll take a look at that first. But then once we get done doing that, the vast majority of this note set and these videos will be factoring, right? Just refreshing your memory on ways to factor quadratic equations. Again, you would have done all of this in Algebra 1, including a pretty difficult technique known as completing the square, which we won't cover in this section, but we will get to here very shortly. But again, it's all stuff hopefully you have seen in Algebra 1, and if you haven't, don't worry, we'll go over all of it here again. But it should hopefully for most of you be a review of factoring techniques you learned in Algebra 1. So let's just jump right into this. Here we go. What we've already looked at is, of course, solving quadratic equations by graphing. All right, we've spent quite a bit of time on graphing. You should be very comfortable at this point with graphing a quadratic equation and finding either its roots, its x-intercepts, or the consecutive integers in which you will find, or the consecutive integers between which you would find the zero or the x-intercept. But what we want to do is take a look at factoring in these notes. But before we get to that, we're actually going to do this first. What is going to happen is if you're given the roots of a quadratic, you're going to use FOIL to go ahead and find the quadratic equation in standard form that would give you those solutions. Now what I've done is I've just reviewed for you here FOIL, because it's probably been a while for some of you since you've had to use FOIL since Algebra 1. But again, FOIL is just an acronym that stands for first, outer, inner, last. And we use that FOIL acronym to help us multiply two binomials together, right? Once you get done doing FOIL, combine like terms and you'll be all set. Now, the equation we're going to use, the formula that we're going to use to help us with this is this guy right here. And what's going to happen is P and Q represent the roots or the solutions to the quadratic. You'll plug those roots or solutions in for P and Q, you'll FOIL it out, combine like terms, and you'll have your quadratic equation in standard form. So let's go ahead and try one of these, see what it looks like. What I've got for you here on the next page of the notes is a couple of example problems. So let's run through each one of these just to see how these work. What I've done is I've given you the roots of the solution. Again, what this is this means that if I were to graph the quadratic equation, if I were to graph it, it would cross the x-axis. Right? Its x-intercepts would be at -1/3 and a +6. -1/3 and a +6. What I want to know is what quadratic equation in standard form has those roots or solutions. So here we go. First I need to figure out P and Q, which are given to me in the problem. We'll go ahead and make P the -1/3, and we'll make Q the +6. Now remember, my formula is this. 0 is equal to x minus P Let me fix my p. X minus p and x minus q. Again, the fact that I'm using p's and q's doesn't really matter. If your teacher uses m's and n's, or t's and s's, or u's and v's, right? It doesn't matter. Those guys right there just represent your roots, right? So that's what we're going to plug in. 0 is equal to x minus, careful, watch your signs. My first root is a negative 1/3. And then x minus 6. Okay, great. Well, a negative times a negative is going to be a positive 1/3. So let me do that first, and then we'll jump right into foiling. Let me leave myself a little bit of space so I can show you the FOIL method in case you need review with it. All right, here we go. In order to FOIL, we're going to do, let me write it up here. FOIL. FOIL, of course, the F is first, outer, inner, and last. And again, what that's talking about is the terms, right? So when I FOIL, I will do the first terms. That would be an x times an x. And what I would wind up with is an x squared. Oh, sorry, let me leave myself a little bit more space than that. The next one is going to be outer, so that is going to be the outer terms in the binomials. So that would be these guys. And that would give me, let's see here, actually here, let me color coordinate this since I've got the colors, I might as well. My first terms got me an x squared. My outer terms are going to get me a minus 6x. Next is inner, that's going to be the inner terms, so that would be these guys right here, which is going to give me a positive 1/3 x. And then finally is L, which stands for last. That's going to be the last terms in each of the binomials. 1/3 comes last, the negative 6 comes last, and so we would multiply those guys together. And what I wind up with is a negative 6 times 1/3. The 6 divided by 3 would be 2. So you wind up with a negative 2. All right. Hopefully you can see that. Now all I need to do is just combine my like terms. So 0 is equal to x squared. In order to combine these like terms, I need a common denominator, which means I'm going to need to multiply top and bottom by 3. So what I'll wind up with is negative 18 thirds x plus 1/3 x minus 2. Let me bring my work up over here so you can see it. And I wind up with x squared. Negative 18 thirds plus 1/3 should leave me with negative 17 thirds. And then I have my x, don't forget your x, and then my minus 2. That's all equal to 0. And now the last thing I need to do to get this into standard form, right? Remember, it's ax squared plus bx plus c is equal to 0. So I got it in the right order. But my a, my b, and my c have to be integers. So I got to get rid of that 3. And I'll do that by multiplying everybody by 3. So I wind up with 3x squared minus 17x. And then I wind up with a negative 6. Is all equal to 0. So there you go. What you've got here is this quadratic equation, 3x squared minus 17x minus 6. If you were to solve it by factoring, which would be the reverse of what we just did, you would wind up with the roots of negative 1/3 and a positive 6. I got another one here for us right here. So let's go ahead and give this one a try. Again, please feel free to work ahead if you would like and come back and check your answer with me. So here's what we have got. Hang on, did I think, 1 second, let me just double check this real quick. 6 times 3 would be 18 thirds, 18 minus 1, 17 thirds. Yeah, awesome. Okay, we're all set. We got it. Okay, my P and my Q. My P is equal to 3/4. My Q is equal to a -5. Let's go ahead and plug that stuff into my formula, which was this. 0 is equal to x minus P times x minus Q, and we will have x minus 3/4 and x, careful, watch your signs, minus a -5. Let's go ahead and clean that up. That'll be a +5, so 0 is equal to x minus 3/4 times x plus 5. And now we go ahead and FOIL it out. Since I did the FOIL in the previous one, I won't draw all my arrows this time, although drawing arrows is perfectly okay. Please feel free to do that if you would like. I wind up with 0 is equal to x times x would be an x squared. X times 5 would be plus 5x. -3/4 times x would be a minus 3/4 x. And a -3/4 times 5, -3 times 5 would be a minus 15/4, -15/4. Okay, here we go. Let's go ahead and combine our like terms. I can do that by finding my common denominator of 4, so I need to multiply top and bottom by 4, which means 0 would be equal to x squared plus 20 over 4x minus 3/4 x minus 15/4. Okay, awesome. Combine my fractions now. 20 minus 3 would be 17/4. So 0 is equal to x squared plus 17/4 x minus 15/4. Let me come up over here just to finish this guy off for you. Now again, standard form, I need to go ahead and get rid of those denominators, which I can do by multiplying the whole thing by a positive 4. That's going to give me 4x squared plus 17x minus 15 is all equal to 0. And there we go. I've got my quadratic equation in standard form that gives me the roots 3/4 and -5. Again, these problems should be really straightforward. It's just the FOIL method, as long as you remember the little formula where you just plug the roots that you're given in for P and Q. From there, it's FOIL and simplify by combining like terms. What we're going to do on the next couple pages of the notes is move on to the second objective. We're going to go ahead and look at factoring techniques to go the opposite direction. I give you the quadratic equation or formula, quadratic equation, and you need to work backwards then to find those roots using the factoring techniques we'll take a look at. So head on over to the next page of the notes, and I'll meet you guys there.